Hi everyone, Retro Shaper is here. In this tutorial series, I want to show you how to use Blender's geometry nodes to create procedural growing stylized trees in just 3 episodes. Now let's roll. So I'm in a new Blender project and I'm using Blender 3.1.2. First thing I want to do right away is to start organizing my assets within scene collections. I'm going to rename my collections accordingly. The first one to cameras and lights, and the second one to my trees. I will also rename default cube to procedural tree. I'm ready to go to geometry nodes layout. After reorganizing the workspace a bit, I'll create a new geometry nodes with procedural tree object selected. I want to name it 3gen to identify it easier among other geometry nodes. I'll disconnect the default geometry and add a curve line primitive, which I'll plug into the group output. I want to set this curve to direction and give it a reasonable length, about 3 meters. Now this length value is going to be the height of my tree. That is why I will add this value as an input to be able to adjust it from modifiers properties. Since this curve has only 2 points, I want to resample it to add additional points to work with. Now I'm going to use set position node to displace each of the points of the curve. The displacement is going to be driven by a noise texture, which I will plug into the offset input socket of the set position node. Now I can see that displacement works, however the whole curve got slightly shifted. But there is an easy fix for this. I'm going to add map range node after the texture and simply remap the values into a target range from -1 to 1. Finally, I can play with noise texture values like scale, details, roughness and distortion to get interesting curve shape. As for the strength of this displacement, I can use target range from the map range node. So I will add max value to the group input, as well as multiply it by -1 for the minimum value. Now I can adjust noise texture strength and modifier properties. Now I want to have displacement more intensive at the top of the tree and less intensive at the bottom. For this, I'll have to get the factor of this curve. I will add capture attribute node right here and feed it with a spline parameter factor. And now I will add another map range node. Plug this captured attribute in the value, displacement strength input value into the max socket, and reconnect the result into the noise texture right here. Now I can see that the strength of the displacement is getting higher towards the top of the curve as long as minimum value stays 0 or less than the max value. Now I can see that the points offset works only in one direction. This is because I apply the same offset for all the axes at the same time. I will use combine XYZ node in between map range and set position. I will leave existing noise displacement nodes connected to X, and I will copy same nodes for the Y. Both of these can share the same strength input. The only thing left is to slightly change the noise scale for one of the axes. Now that the base curve for the trunk is ready, I want to start building the growing logic. Luckily, there is a trim curve node. I'll add it right here, and with the end slider I can adjust to what point my curve will be trimmed. I've decided to add this to the group input right away. And I did it because I wanted also to influence the strength of the curve displacement. To make it happen, I'll add another map range node. I'll plug an input into the value of the map range. The displacement strength value should go to the max socket here, and the result of this map range goes to the maximum value of this other map range node. So what happens here, the displacement strength will be driven by the end value, which happened to be the tree growth. Now it is time to add some geometry to this curve. I'll use curve to mesh node with a curve circle as a profile curve. I'll drop the resolution of the circle to 8 and decrease the radius to something around 0.1. Now I want this mesh to become thinner at the top. That is why I'm using set curve radius node, which I can feed with the value based on the curve parameter. I'm going to capture another attribute with spline parameter as a value. And it is important to capture this one after the trim curve node. Now when I plug this attribute into the radius, I can see that I get the exact opposite result. To fix this, I'm going to use map range again, and I will simply switch the minimum and maximum values of the target range. I can even use float curve to give some additional thickness modification to the curve and control how intensive it is with factor slider right here. Let's test the growing of the tree. It appears the trunk doesn't get thicker when getting small, which doesn't look realistic. I can fix that by plugging end input value into the minimum value socket of the map range in order to synchronize width with growing stage. To make this effect better, I will multiply the radius of the curve by the growing value. Looks great. Now I'll put all of the values that I need into the group input for convenient configuration in the modifier properties. Such settings like length, resolution, displacement scale on X and Y axes look the most important to me. For more convenient usage, I'm going to rename all those input values accordingly. I will also add frames to some specific groups of nodes. Now it is time to build up base for branches. What I want to do is to create branches on specific points of the trunk curve. I'm going to use instance on points node. I will use trunk curve as the point, and it is important to take it after the capture attribute node, since I'm going to use this captured attribute for a branches configuration. For the instances, I'll add curve line. In order for instances to appear on the trunk, I need to join both the instances and trunk curve into a single geometry. All the branches look up, same as the direction of their curve, so I'll adjust the rotation on the y-axis for better visibility. I will also bypass conversion of the trunk curve to mesh in order to better see what's happening. Currently, branches are instanced on every single point of the trunk curve, which doesn't look right to me. So I want to select specific points where branches will appear. I will use compare node, and I will put index into slot A, and check whether my integer value, which is slot B, is greater than that index. I'll plug that into the selection socket. Now I can specify the starting point where branches will appear. I can use similar method to deselect points from top. I'll add another compare node, this time with less than or equal comparison, plug the same index value into a slot A and use it as a selection. It works, but in a slightly different way that I need. What I want to achieve is to deselect points from the top. To get that result, I'm going to use spline length node and subtract integer value from the point count. The result of this subtraction should go to the slot B of the compare node right here. Now I can deselect the points from top on the trunk curve. To combine both of these selections, I'm going to use math multiply operation. Looks great. And it works regardless of how many points do I have in my trunk curve. Of course, I don't want branches to appear on every single point of the trunk, even within my existing selection. That is why I'm going to use random value node, which has Boolean operation. With Boolean selected here, I can set probability and seed, which will output true or false value. To combine that with my other selections, I'll use another math multiply operation. Now, to save some space here and to easily reuse this set of nodes, I'm going to create a group of all of these nodes with Ctrl-G. I'll put all the variables for configuration into group input, such as selection from top, from bottom, probability, and seed. And I will rename these inputs accordingly. I'll exit the group with an arrow right here and rename this group to select points on curve. The selection of the points will also work with tree growth without re-instancing of the branches. Now I want to change the size of the branches based on their location on the trunk. All I have to do is to plug already captured attribute of the trunk curve along with map range and float curve into the scale socket on instance on points node. To better see what happens and to verify this approach, I will crank up the probability of the branches and point selection. It is time to work on the branches rotation. First, I'm going to add combine XYZ node to make calculation for each individual axis. At the same time, I would like to give branches a direction based on the trunk curve displacement. For this, I will use curve tangent and align Euler to vector nodes. Combine XYZ, or in other words, my manual rotation, will go to the rotation socket and curve tangent as a vector. This way, I align a given rotation with a curve tangent vector. I can also change local axis of the object that is to be rotated towards the vector input. Now, as you can see, branches will get a direction in sync with the displacement of the curve. Now I want to randomize branches rotation on the z-axis. For this, I'm adding random value node and plug it into z-axis of combine XYZ node. For combine XYZ node to accept and understand value in degrees, I'm going to add a math node right here and select conversion to radians as an operation. And now I can specify a random range for the rotation on z-axis from 0 to 359 degrees. Since we align Euler to vector, we've changed the logic for rotation on the other axes. And I really want to have more control over the rotation. So I'm going to add rotate instances node. After playing with some of the inputs, I've identified that I want to change rotation on x-axis based on the position on the trunk. Branches on the top should look more up, and at the bottom should look more down. So I'll add combine XYZ node with conversion to radians into the x-axis. And a map range node plugged into the math node here. Already captured trunk spline factor attribute should go as a value for the map range. And now I will set the range of rotation on x-axis based on the trunk spline factor. After a few minutes of tweaking, I found the best range for me, from 50 to -60. Now let's check how it works with the growing. Amazing, branches scale and rotate with the growing. However, they look a bit static. To give them more realistic growing, I'm going to multiply tree height value by the growth value. Now it seems like branches move along with the trunk. Additionally, I want to add trim curve node to the branches and control end of the curve with existing tree growth value. Now branches have a similar growing effect, which will be more noticeable later with geometry applied and twigs and leaves scattered on them. Now I want to reconnect the conversion to mesh for the trunk and use the same method for the branches. I'll convert curve to mesh with curve circle as profile curve. Decrease the resolution. And I'm going to feed the curve radius with trunk width value multiplied by 0.5 to have width consistency between branches and trunk. To make branches thinner towards the end, I will use set curve radius node again. And capture spline parameter factor as attribute for the branch instances. I'll plug attribute into the radius and configure the width range with map range and float curve nodes as I've already shown for the tree trunk. To see the float curve details, I'll need to resample branch curve to create additional points. Even though branches are scaling based on the tree trunk factor, I still want to adjust their width by multiplying by tree growth value. As well as feeding map range with the same value for more realistic result. And that's about it for the first part of this tutorial. In the part 2 of this tutorial, I will be doing branches and twigs collections to build interesting configurations of trees and to have flexibility and variability. So I hope to see you in the next video. Thank you very much for watching and have a wonderful day. Bye bye.